Welcome to online classes of Malabar Engineering College. Today I gonna take on a subject Machine Design 2 which comes under S6 Automobile. Okay, here first I gonna explain like what's meant by connecting rod. We know there is a link between the piston and the crankshaft, and between the piston and the crankshaft lies a connecting rod. Okay, the connecting rod is nothing but its functions like it converts the transverse motion into rotational motion. That's the purpose of a connecting rod placed between a piston and a crankshaft. Okay, so now let's do a problem related to a connecting rod. Okay, now I'm gonna explain what's like the problem. Determine the dimension of a cross section of a connecting rod for a diesel engine with the following data. Cylinder bore 100 mm, length of connecting rod 350 mm, maximum gas pressure 4 megapascal, factor of safety 6. Okay, here there is a connecting rod and we need to have a cross sectional area. We need to find the dimension of the cross sectional area. Like when we take a connecting rod, there are like various dimensions like length, breadth, width. Like there are several dimensions. We need to find the dimensions. Okay, for they have given the data like D. D is like the cylinder bore, the cylinder bore diameter, and we have P max maximum gas pressure, that is 4 megapascal. We converted to Newton per mm square since it's a pressure. It's a type of a force, so we need to convert to Newton per mm square. And we have length of the connecting rod. The length we have 350 mm, and we have factor of safety. Like how much the factor of safety? We have like 6. For this, the first step of the problem is to find the force acting on the connecting rod. We need to find how much force is acting on the connecting rod. For that, in the data book, we have an equation. PC is equal to pi d square by 4 P max. Okay, here PC is the connecting rod force, and we have the given data as pi into 100 square. We have the like 100 square d diameter, it's 100 mm, 100 square by 4 into 4. Like we have P max as 4, and we get 31,415.93 Newton. That is the force acting on the connecting rod. Okay, that's the first step. And next we need to find a critical buckling load. It's nothing like when the force is in maximum, the connecting rod will buckle, like it will tend to break. It will be like bending. Like that, the buckling load will start. At what load the buckling starts, we need to calculate that the second step, and it's like critical is equal to PC into factor of safety. Like the value we find here, multiply the factor of safety. Like the factor of safety is how much limit it can be gone without any buckling. So like that, we multiply with that, we get 18849 5.58 Newton. That's a maximum buckling load, and that's the second step. And the third step which we get from the data book, and we need to calculate the value of small t, and that's like we get from the value equivalent to the critical buckling load. It's in the data book. A is equal to, that means the area. A is found out by A is equal to 11 t square. Kxs, it's like the safety, is equal to 1.78 t. A is the area, A is equal to 1 by 7500, and sigma is a stress, sigma C is equal to 330 Newton per mm square. And we substitute in the equation P sigma is equal to sigma C A by 1 plus A or L by K xx the whole square, and we substitute these values into this equation of sigma P sigma. The value of A, the value of Kxx, value of sigma C, and we get a quadratic equation like t raised to 4 minus 5 51.93 t raised to square minus 267.960, and this quadratic equation we need to solve using the simple mathematical formula like minus b plus or minus root b square minus 4ac by 2a, and we get the values, and we get the value by substituting in that equation, basic mathematical equation. We get the value of small t is equal to 7.53 and we round the value as 8 mm. That's the thickness T. And once we found out the thickness, then we have like the breadth, which is in the already the data book. Like breadth is equal to 4 into T is equal to 4 into 8, that is 32 mm. And height is 5 into T, that's 5 into 8, that is 40 mm. And width is equal to, the width and the breadth is same because it's a constant. Since this is a constant, the width and the breadth is the same. And that's how we calculate the value of breadth, height and width of the connecting rod, and we found the values like that. By this, I conclude my today's class. Thank you.